Right now, a quiet but extremely powerful transformation is taking place in the technology world, and at the center of this process is Tesla, which has long moved beyond being a traditional automaker and is gradually becoming a company that creates fundamental technologies of the future. If not long ago, the main attention was focused on electric vehicles and autopilot, today the focus is shifting to a far more ambitious project, Optimus. And it is around this project that one of the most promising and at the same time most complex technological breakthroughs of recent years is now taking shape. Over the past year, progress in this direction has been significantly faster than even close industry observers expected. And within Tesla itself, this project is no longer seen as an experiment, but as a key element of the company's future strategy. In essence, Optimus is meant to become a universal platform capable of performing a huge number of tasks in the real world. But on the way to this stands one of the most difficult problems in modern robotics: movement. And here it is important to understand one simple thing: a robot's intelligence can already be brought to a very high level today, but if its movements remain mechanical and unnatural, it will never be able to fully integrate into the human environment. That is why Tesla is now focusing not only on software, but also on a fundamental transformation of the robot's physical architecture. According to information from the industry, Elon Musk has set the team a task that sounds almost impossible: to make the robot's movements as smooth, precise, and natural as those of a human. This means not just improving existing mechanisms, but essentially rethinking the very principle of how actuators work. Classical motors and rigid mechanical systems have already reached their limits in terms of natural movement. They can be fast and precise, but they lack flexibility and adaptability. That is why Tesla has begun developing next-generation artificial muscles, systems that do not just move parts of the robot's body, but imitate the very principle of how human muscles function. These are flexible structures capable of contracting, stretching, and adjusting force in real time. Such robotic muscles make it possible to achieve an entirely different level of motion control, where every action becomes smoother, more natural, and more adaptive to the environment. Of course, fully replicating human muscles at the current stage is impossible, but approaching their functionality is a realistic goal, and this is exactly what engineers are focusing on. They are creating hybrid systems in which new materials, sensors, and algorithms work together to form a unified, adaptive structure. This means that the robot does not simply execute commands, but literally feels its environment. It can regulate grip strength, adjust movement speed, adapt to uneven surfaces, and do so instantly without delay. This is where the main shift occurs. The robot stops being a set of pre-programmed actions and begins to behave like a system capable of adaptation. This is a fundamentally new level. Interestingly, Tesla is simultaneously using its experience in artificial intelligence to teach the robot to move the way humans learn, through observation, repetition, and error correction. This allows the system to continuously improve its movements over time, making them increasingly natural. And if you put all of this together, it becomes clear just how complex the task is. Several fields intersect here at once: mechanics, materials science, sensor systems, and neural networks. Each of them requires a separate level of expertise, and their combination turns the project into one of the most complex engineering challenges of our time. But that is exactly where the potential lies. If Tesla manages to bring this technology to a stable working form, it could become the moment when robots stop being perceived as machines. Smooth movement is not just a visual effect, it is the key to interaction with the world. It is the ability to work safely alongside humans, perform delicate tasks, and adapt to unpredictable conditions. Moreover, such technologies may extend far beyond robotics. Artificial muscles could become the foundation for a new generation of prosthetics that would not simply replace lost functions, but enhance them, opening an entirely new level of possibilities in medicine. Nevertheless, the main focus of Tesla remains the creation of a universal robot. Optimus is seen as a platform that can be scaled into virtually any field, from industry to everyday use. And if this project is realized, the consequences could be enormous. A new class of universal workers will emerge, capable of performing a wide range of tasks without fatigue and with high precision. This will inevitably affect the labor market, the economy, and the very structure of society. But right now, we are only at the very beginning of this path. The technology is still taking shape, and it is at this stage that its key principles are being defined. And judging by the current pace of development, Tesla may indeed become the company that first brings us closer to the moment when the distinction between humans and robots begins to gradually disappear. And perhaps this moment will become one of the most important turning points in the history of technology, after which the world will never be the same. But the most interesting part begins further, because within the industry, discussions are increasingly focused not on the technologies themselves, but on the speed of their deployment. And here, Tesla has a serious advantage that is rarely discussed openly. The company already has vast experience in scaling complex systems, from the production of electric vehicles to the deployment of autopilot. And this experience could play a decisive role when it comes to mass production of robots. Because creating a prototype is only half the journey. The real challenge begins when the technology must be turned into a product that can be manufactured in thousands and millions of units. And if Optimus truly receives those artificial muscles and a new motion architecture, the next stage will be optimization of cost, reliability, and maintenance. And this is where another important point emerges. If Tesla manages to make such systems sufficiently affordable, it could sharply accelerate their adoption. First in factories, where robots will be able to perform repetitive tasks with high precision, then in logistics, warehouses, and service industries, and only after that in everyday life. In practice, we may see a gradual penetration of such robots into different sectors, where they will become increasingly familiar, first as tools, then as assistants, and eventually as full participants in processes. And it is at this stage that the most interesting developments will begin, because when a technology becomes widespread, it starts to evolve even faster. New use cases appear, new requirements emerge, and new improvements follow. And if we put all of this together, it becomes clear that the Optimus project is not just another development, but the foundation for an entirely new industry that is only beginning to take shape. And if the current pace continues, the moment when robots begin to move and act as naturally as humans may be much closer than it seems today. This opens the door not only to new possibilities, but also to a fundamentally different societal attitude toward robots. When movements become natural, the psychological barrier disappears and the machine stops being perceived as an alien mechanism. Optimus is gradually transforming from a technical experiment into a future companion, capable not only of working alongside humans, but also of subtly adapting to their rhythm, habits, and even mood. That is why the next few years will be decisive. Whoever is first to combine perfect motor control with true understanding of the surrounding world will define what the next chapter of human civilization will look like.